Okay, we're going to take a look at some what is known as a logarithm here. And what is interesting is about this is there is a relationship between an exponential function and a logarithmic function, right? So an exponential function means there are variables in the exponent. And we're going to look at what this is, okay? And to start, let's just look at the exponential function. So if I've got a point 0, 1, and then I look at the next point on this graph, I've got 1, 2, right? Because 2 to the first power is 2. And now I've got 2 to the second power, or 2 squared, is 4, right? If I'm putting a 2 in there, 2 squared is 4. Now I've got 2 to the third power, so 2 to the third power would be 8. And then it's not on the graph, but 2 to the fourth power, if I've substituted a 4 in here, right, we're going to get 16, okay? Now, if I go ahead and look at this logarithmic graph right over here, all right, we can substitute in the first point. So if I find the first point is 1, 0, all right, I would say log base 2 of 1 is 0. And then I look at the next point on the graph, and I'd see a 4, right? So log base 2 of 4 is 2. And then I look at the next point, 8, right? So log base 2 of 8 is 2. So if there's an 8 in there, we're getting 3, right? And now we get 16. Log base 2 of 16 is 4, okay? So what do we notice about this relationship and this relationship? 1 to 2, okay, right? 2 to 4, 4 to 2, right? 3 to 8, 8 to 3. Okay, and what do we notice here? Well, we notice that the x and the y values are switched. So what is our mathematical term for switching the domain and the range? Is an inverse, all right? So we have an inverse, okay? So our general rule for the conversion here is if I've got a function, you can see that they're inverses here because they're graphed, and they're graphed right along the line y equals x. Like all these points are graphed and reflected across the line y equals x. Okay, now if we're going to convert here, if I've got a function like y equals b raised to the x, okay, I can convert this, right? I'm going to switch my x and y and convert to this function right here. Okay, so y equals log base b of x is an equivalent form of y equals b to the x, all right? So now let's take a look at how to represent some of these things. One way to think about it is log could mean to the what power, all right? So if I don't know what this is and there is nothing there, this is a common log. It means log base 10, right? So if I don't know what this is, I set it equal to x. And now I'm going to convert. So 10 raised to the x is equal to 10. So I'd say 10 raised to the x is equal to 10. Now, what power is really up here? 10 to the 1, common bases, x equals 1. Okay? Next one, right? It's a common log. So what's the base? 10. Do I know what it is equal to? No. You can think about it as 10 to the what power is 100, right? So I say 10 to the what power is 100. So 10 to the what power is 100. Okay, now using our common bases, right? 10 to the x equals 10 squared. So now we have a common base here, a common base here. We know that x is equal to 2, or 10 log base 10 of 100 is 2. Okay, moving on to the next example. All right, do we know what this is? No, it's a common log. So 10, it's equal to x, all right? So 10 raised to the what power is 1/10. So let's do it, right? So 10 raised to the what power is 1/10. Okay, so now we just did this. We can simplify this. So 10 to the negative first power. Okay, so we have common base. So now we know our x value is equal to -1. So we could say log base 10 of 1/10 is -1. Okay, moving on over here. Do we know what this is? No, it's a common log. Okay, so we know it's a number, just equals something. So follow our rule. 10 to the what power is 1 over 100. So 10 to the what power is 1 over 100. Okay. Rewrite the common bases if you can. So 10 to the x equals 10 to the negative second power. Remember, negative exponents don't mean negative numbers. Okay, it just means that we are converting to a fraction, right, of some sorts. Okay, so our x is equal to negative 2. Okay, so those are all common log examples. Common log means log base 10. All right, now let's look at some different log examples. All right, log base 2 of 8 is what? So 2 to the what power is 8. Okay, mentally, we got to think about that, right? So now, if I don't know what this is, we can rewrite it. So 2 to the what power is 8. So 2 to the what power is 8. So use our logs here. So I've got 2 to the x equals 2 to the third. Now I've got common base. So we've got x equals 3. All right, so you can say log base 2 of 8 is 3. Okay. Hopefully by now you should be able to spot this, right? Log base 3 of 9 is what number? Okay, so if I don't know what it is, set it equal to x. Right, so 3 to the what power is 9. Right, so 3 to the what power is 9. Rewrite it so we can find a common base here. And then now, do we need our bases anymore? No, you don't. Okay, our x value is 2. Or more simply, log base 3 of 9 is 2. Okay. Sliding on to this one, okay? Log base 3 of 81. If you're not sure what it is, set it equal to x. All right, so 3 to the what power is 81. 3 to the what power is 81. Okay, so now we've got 3 as our common base. Okay, so 81 would be 3 to the fourth power. Got a common base. So now we know that our x value is 4. Or again, what can we say? Well, log base 3 of 81 is 4. It's a number. Okay? All right. And again, now we're looking at this, so we know we're thinking it's probably going to be a negative exponent, right? We should kind of have that down by now. If we're not sure what it is, set it equal to x, and then let's just solve, okay? So I've got 3 to the what power is 1 over 27. 3 to the what power is 1 over 27, okay? So I've got 3 to the what power is 3 to the negative third power. Now we have a common base. So we know that x equals negative 3. Now remember, this is just a number. Okay, log base 3 of 1 over 27 is negative 3. Okay, so these are expressions here. And now we're running into equations where now we have an equal sign. We know what we're going to have to evaluate right here. So when you have these equations, it's best to just follow your rules, right? So I've got x raised to this to the third power is 125. So what number to the third power is 125? Okay, so now on a little side note here, right, you can use your tables or you can use your chart, but algebraically, if I want to get to x to the first power, I know I need to multiply 3 by 1/3. Okay, because right up here, if I've got 3 times 1/3, I'm going to get 1. Right, so if I raise both sides to the 1/3 power, okay, I'm going to raise both sides to the 1/3 power. This means the cubed root of 125, or you can use your calculator, and you're going to get a value of 5, right? All right, let's flip it over here. Next example. Okay, now we're looking for what the log is. 2 to the what power, 2 to the fifth power is what number, really? That's what we're saying here. Okay, so if I follow my rules, 2 to the fifth power is x. All right, so I've got 2 raised to the fifth power is x. So now we can just evaluate straight in our calculator. So 2 to the fifth is 32 is equal to x. And if, again, this is just a number, right? So log base 2 of 32 is what? 2 to the what power is 32? Well, 5, okay? And then last example right here, okay? A little bit of a confusing example. We've got a fraction now, but follow your rules. So x raised to the 3 halves is 512, okay? So I've got x raised to the 3 halves is 512. Okay, so now if we jump to our calculator here, just want to make sure that we're understanding what we're doing. Remember, if I want to get x to the first power, if I raise this to the 2/3, okay, what's happening here is now I've got 2 times 3 is 6. Oh, I'll highlight that instead. All right, 2 times 3 is 6. 3 times 2 is 6. 6 over 6 is 1. Okay, so now in our calculator, if we wanted to evaluate that, just make sure that when you're evaluating that in your calculator, you're using fractions, right? So if I type into my calculator 5 raised to the, either use a parenthesis or a fraction, 512 here raised to the 2/3 power. Okay, and if you enter that in your calculator, we're going to get an x value of 64. Okay, all right. In general, when we're talking about logarithms, right, here we're talking about exponents, and that's kind of really the key. Rather than talk about the numbers as their base elements, okay, we can talk about numbers as exponents. We can talk about outputs as exponents, okay? All right, hope this helps. Good luck.